Okay, so specialization and generalization. Okay, issues of specialization and generalizations, they are associated with two things. I said superclasses and subclasses, and then also they are associated with what we call inheritance, which could be attribute inheritance or relationship inheritance. So a supertype or a subclass, a superclass, they are used when there exists entities that share common properties. So each supertype contains a shared property of all the subtypes. I am going to show you exactly what we mean here. So what is a superclass? A superclass is an entity that includes one or more distinct subgroupings of its occurrences, and a subclass is a distinct occurrence. So what happens here? One thing that you need to know is a relationship that exists between a subclass and a superclass is always a one-to-one relationship, which can either be mandatory or it can be optional. So a subclass a subclass may inherit some or all of the attributes of the superclass. So before we explain why class and subclass relationships and specialization, let's first go and I demonstrate this aspect. If I come back here, okay, let me first reduce some of these entities because it looks like there are quite many. Okay, so let us assume that you have an entity called employee, which is a superclass. This employee has an employee ID. This entity has employee name. And this person has a date of birth, etc. So an employee can be one, let me first delete this. An employee can be a secretary or can be a driver. Okay, can be a secretary or can be a driver. Okay, now these two, we have what we call attribute inheritance. I think I can have this and then have that. Okay. Okay. And then we have this. I'm trying. So specialization is represented by a triangle. That triangle represents inheritance. It shows that gosh. Okay, now this is what we call specialization. Now, this one here that you see up here is referred to as a superclass, this one here. And this, what you see here, these are subclasses. Now, these subclasses, okay, I say the relationship that exists between a superclass and a subclass is always a one-to-one relationship. However, the participation can be mandatory or it can be optional. So this is where we put you're saying that it can be a mandatory or an optional. So sometimes you say mandatory. It can be mandatory or it can be optional. So in essence, here, of course, I have represented two things. It can be a mandatory relationship, or it can be an optional. The different types of constraints are such that you have a mandatory, or you have an optional, or you have an optional, or, and then you can have a mandatory and or an optional and. Later on, towards the end of the lecture, I'm going to be discussing constraints. But what is most important for you to understand is, one, that the relationship that exists between this superclass and these subclasses is a one-to-one, but the kind of participation can be mandatory or it can be optional. So employee, what does this inheritance? The inheritance sign is represented by a triangle on top here. What does that mean? It means that these subclasses are inheriting all the attributes of the superclass. All these attributes, that is why you say a secretary is an employee, a driver is an employee. So this triangle is also sometimes referred to as an is-r angle. So you is-r symbol. So now you have a secretary is an employee and a driver is also an employee. So implying that a secretary has an employee ID, a secretary has an employee name, a secretary has a date of birth. A driver has an employee ID, a driver has an employee name, a driver has a date of birth. So this is the aspect of inheritance. Everything that you see here has been inherited by these subclasses. However, these subclasses could be having some attributes that are unique to that particular subclass only. So for example, a secretary can have typing speed as a unique attribute that only applies to the secretary. The same thing, a driver may have what we call maybe a driver's license. That is unique to the driver. It's unique to a driver. So by putting these unique attributes down there, it means that these if I put driver's license up here, it would mean that a secretary has a driver's license. Yet that is not the case. If we put typing speed up here, it means that the driver will also inherit typing speed, which is not the case. So that is how we deal with aspects of specialization and generalization. And the most important is it's not only the attributes that they inherit, but they also inherit the relationship types. So for example, you can say that an employee takes on a course. Employee, okay, that is supposed to be a line. It's not supposed to be an arrow, okay? So an employee takes on a course. Okay, maybe there are trainings that they do. So here you bring this and then we put it here and then we say employee takes on, Control C, Control V, and then we say, okay, enrolls. Yeah, that's perfect. Employee enrolls for a course. Now, when we're talking about, we said attribute inheritance and relationship inheritance. So these subclasses not only inherit the attributes of employee, but also this relationship type that employee is participating in. So what does that mean? That a secretary enrolls for a course, a driver enrolls for a course. So driver and secretary are also inheriting the relationship type enrolls for. Meanwhile, they're also inheriting the attributes of employee. So any relationship type that employee is going to participate in, also these two are going to inherit. That is the aspect of inheritance. So certain attributes may apply. So they are saying certain attributes may apply to some, but not all the entities of the superclass. We are saying, why do we need this class and so subclass relationship types and specialization? It is because some attributes may apply, like what I have said, the attribute of typing speed can only apply to the secretary, whereas the other attributes that we had in employee are applying to all the subclasses. So this is the example here. You have an employee superclass that has all these attributes. However, secretary has this typing speed as a distinct attribute. The same applies to engineer, who is an employee. They share all these attributes, but then engineer type is distinct and T grade is distinct. So if you have those distinct attributes, that the way I represented them in the previous diagram, that is how you're supposed to represent them also when you're dealing with them. So the properties of subclasses and superclasses. One, a member entity of the subclass represents the same real world entity. In other words, the subclass that you saw is actually a real entity and it can exist in the database. The subclass member is the same as the entity in the superclass. In other words, that it is the same entity, or it can exist in the database. That is the subclass. So the subclass secretary exists in the database. The subclass driver exists in the database. What may be different is that they have distinct specific roles. So when you are implementing these subclasses and superclass relationship, a member of the subclass may be represented as a distinct database object. So the properties continue. An entity cannot exist in the database by just being a subclass. An entity cannot exist because remember that subclass always has to be a member of a superclass. So it cannot exist in the database just by being a subclass. And an entity can be a member of more than one subclass. What am I saying? That a superclass can be a member to more than one subclasses. If you go back to the other demonstration, you can have a situation where you have an entity employee who is either a driver or a secretary. But there are some instances, if I go back, I love to demonstrate this properly. Okay. So this is supposed to be an arrow. So we are saying that this superclass can be a member of more than one subclasses. What does that mean? It means that I can be, okay, this has to go. Let's go to extend that side. Control-C, Control-V. I'm going to represent Control-C, Control-V. So what does that mean? I need to size this a little bit. So we can put here and we say this person can we say manager? Okay, where you have a manager ID. Okay, that could be the only distinct role, but it's not a primary key. This is not a primary key. This is not a primary key. Manager ID is just a foreign key. Rephrase it. So now we create this goes there, and now we bring this. This is supposed to be okay. So now these are three entities, three subclasses. We are saying that a superclass can participate in more than one subclass. So you can be a secretary, but when you are a manager, or you can be a driver, but when you are a manager. Okay, you've seen someone comes, like for example at Makerere University, where someone is a dean, but someone is also a lecturer. Someone was initially a lecturer, but then as rising through the ranks, then they become a dean. So that means here you will be having, for example, you will be having a subclass called dean, and then you also have another subclass called lecturer. So that is where we're saying that a particular relationship type can have, an entity can be a member of more than one subclass. That is what I was trying to explain. Okay. Like this is an example of a salaried employee who is an engineer who belongs to two subclasses. You can be an engineer but a salaried employee. So it is not necessary that every entity in the superclass can be a member of the subclass. So in essence, what this statement means that it does not necessarily mean that a superclass has got to be a member of the subclasses. It does not necessarily mean that. Okay, it does not mean that a superclass must be a member of a subclass. An example is a technical writer is an employee but does not belong to any of the subclasses. So the type the type of an entity is defined by the attributes it possesses and the relationship types which it participates in. What does that mean? That an entity that is a member of a subclass inherits all the attributes of the entity as a member of the superclass, as well as the relationships that that particular superclass is participating in. That is what I explained in the diagram that I drew of employee. So we have specialization. It's a top-down design process. Okay, like I was discussing the top-down design and the bottom-up kind of design. So specialization is a top-down design that starts off with an entity and then creating distinct subclasses for that particular for the superclass. So we are saying that for specialization or generalization, it is depicted by a triangle, which is also represented as an either. This triangle represents attribute inheritance, implying that the entities of the subclass inherit some or all the attributes and the relationship types that that higher entity is participating in or is linked to. So specialization, the same entity type may have several specializations based on different distinguishing characteristics. What does that mean? That an employee, for example, the employee entity type that we can have two specialization. An employee can be, the first specialization can be in terms of method of pay, where an employee can either be a salaried employee or can be an hourly employee. Or you can be in terms of job type, okay? Job type. Again, if I go back here, so what am I, this is by job type. This particular employee, the relationship is by job type. But you can also participate in others, for example, Ctrl+C, Ctrl+V, where unfortunately may not fit as I had wanted, as I want to, okay, where you can have, for example, Ctrl+C, Ctrl+V, and you have a manager here, okay, sorry, you have a salaried person who is salaried, or Ctrl+C, Ctrl+V, an employee who can be an hourly employee, paid hourly, okay, paid hourly, and this one is salaried. And then like what I did, you establish the connection between the two, and unfortunately it may not fit as I had wanted, but let me see what I can do. Okay. So now what I'm simply doing is what I'm simply saying that this superclass, okay, is participating in more than one. So in other words, we are saying that an employee can be a manager, a secretary, or the driver, but this employee is either salaried or paid hourly. So this is what I was trying to demonstrate, and this is what this statement means, that the same entity type may have several specializations based on different distinguishing characteristics. Generalization is the reverse of specialization. It is a bottom-up approach where you start off with the subclasses of a given scenario, and then you incrementally build them into a higher level entity set. So these two, specialization and generalizations, are simple inversions of each other. So there's actually sometimes the words are used interchangeably. Okay, I can say car and truck are specializations of vehicle, and vehicle is a generalization of car and truck. So this is what this means. So it's just they are used interchangeably, and they shouldn't really pose a lot of confusions, because at the end of the day, what you have is a diagram. Whether one will not know whether it is a product of specialization or generalization. All we need to know is it represents those aspects. We have constraints in generalization and specialization. Like I said, you can have mandatory, all mandatory, and etc. But what are these different constraints? One, we have a constraint that we call the disjoint constraint. And this disjoint constraint can be in two types: disjointness and overlap constraint. And then we also have the other constraint, which is participation. Participation can be total or mandatory participation, then it can be partial or optional participation. So what is disjointness constraint? A disjoint constraint specifies that subclasses of the specialization must be disjointed. What are we saying? We are saying that an entity can be a member of at most one superclass. In other words, this particular superclass can be a member of at most one superclass. The moment you see an or, okay, it means that a client can either be an individual or a company, but cannot be both. That is what the or represents. And then the overlap specifies that the subclasses are not disjoint. Okay, they are not constrained to be disjoint. What does that mean? It means that the superclass can be a member of more than one subclasses. For example, a student can do a course, either a student is doing DIM and SAD and internet programming, and so this "and" is a representation of an overlap constraint. Then we go to participation, okay, which we call the completeness constraint, which can be total or partial. Total participation, okay, or total specialization or mandatory constraint specifies that every entity in the superclass must be a member of a subclass. When you see the word mandatory, it means that this superclass must participate in at least a member of must be a member of any of the subclasses. So in this case, where there is mandatory, you can say a student is taking on, a student must take on any course that is given to them. Whereas when you're talking to optional, with the partial specialization, which is an optional participation, it allows the entity of the subclass not to belong to any of the superclasses. What does that mean? It means that you can have, these, it means that this particular employee can be a manager, or it's optional. It does not necessarily mean that this manager is participating in any of the subclasses. So in other words, an employee can this particular employee subclass can exist on its own, or if the participation is there, it can be in either participating in either a manager or a secretary. But it doesn't necessarily mean that it is a must that this employee should participate in any of those subclasses. So these are the 4 possible constraints: mandatory or optional, or mandatory and optional and. Those are the 4 possible constraints in specialization. So these are just illustrations of again, specialization and generalization. This is an optional and, implying that this member of staff, okay, it's optional for the member of staff to participate in any of these subclasses, okay, but the and means that should they participate, then this member of staff can be a secretary and a manager, or this salesperson can be a salesperson and a secretary. So that is what it means. And then the most important also thing to note is the superclass can be this subclass can be a superclass of a subclass. So for example, you have a secretary who is a subclass of staff. But this subclass is also a superclass of another subclass, where, for example, you could have an assistant secretary. Okay, so this creates another specialization. But the kind of participation that exists in this kind of arrangement is always optional participation. Same thing here, you have a manager and a salesperson, so you could have a sales manager, okay, which is this one is a shared subclass between manager and this, but this relationship is an optional participation. So these are the different kinds of specialization. So the difference between specialization and generalization is, 1, the specialization process corresponds to a top-down conceptual refinement process during conceptual design, whereas a generalization process corresponds to a bottom-up conceptual synthesis during conceptual schema design. So this is what I wanted to share with you today. See you in class. Bye-bye.